Hello class, I'm Norman Stevens. I'd like to go over the chapter checkpoint questions from Chapter 7, that is in Economics 101, Chapter 7, Government Actions and Markets. Normally in the on-ground class we would go over these questions in class, either individually or in groups, and then check the answers in the class and that way determine what people get or what people are not comprehending. So one way to mimic that is to try the questions on your own first and then listen to this Camtasia video with the answers, or you can always pause this video at any time and try to work the question out on your own and then hear my answer. And if my answers are unclear in any way, please send me an email and check with me. First question states the following. In Florida, sunscreen and sunglasses are vital items. If the tax on sellers of these items is doubled from 5.5% to 11%, who will pay most of the tax increase, the buyer or the seller? Will the tax increase halve the quantity of sunscreen and sunglasses bought? And the reason why halve is in there is because that the tax is doubled. Tax goes up 2 times, so would that decrease by 50% the quantity of the items purchased? And 2 words actually to keep in mind here are vital items, that is, they're necessities. Consumers have to have them. And we know from Chapter 5, studying price elasticities of demand and supply, that if something is necessary, it really doesn't matter if the price goes up a little bit, people still will purchase the item. An example might be gasoline. Even though the price goes up, people still continue their purchasing habits of gasoline. So, because sunscreen and sunglasses are necessities, the demand for them is inelastic. So, most of a tax imposed on them will be paid by the buyer. Even though the tax doubles, the quantity purchased is not halved because the demand is inelastic. And another way to think about the question too would be the items. Sunscreen and sunglasses are relatively inexpensive, so if the tax on those items goes from 5.5% to 11%, that's really not a huge price increase, hardly noticeable for the consumer anyway. Question 2 states, suppose that the government imposes a $2 a cup tax on coffee. What determines by how much Starbucks will raise its price? How will the quantity of coffee bought in coffee shops change? Will this tax raise much revenue? Again, back to the price elasticities of demand and supply. They determine how much more Starbucks charges for a coffee. The smaller the price elasticity of demand and the larger the price elasticity of supply, the more Starbucks will raise the price of a coffee. The quantity of coffee bought will decrease. The amount of revenue the government raises, that depends on the size of the tax and the size of the decrease in the quantity of coffee purchased. In other words, we don't know that information. For a given tax, the government collects more revenue the smaller the price elasticities of demand and supply, because the smaller these elasticities, the smaller the decrease in the quantity purchased. That is, so the government can still have considerable revenue from the items because the quantity that is purchased does not change very much. Question 3. The table illustrates the market for internet service. What is the market price of internet service? If the government taxes internet service $15 a month, what is the price the buyer pays? What is the price the seller receives? Does the buyer or seller pay more of the tax? So the chart is reproduced here, and you can tell just where the numbers line up what the market price of internet service will be, $20. The market price of internet service is $20 a month because that is the price at which the quantity demanded equals the quantity supplied. And a figure is helpful to answer this question. Figure is shown here. That is, you can take this chart above and plot out the quantity demanded and the quantity supplied lines and the price, and reproduce this chart here with the demand line going down like so, the supply line going up like so. You can see the equilibrium price and the quantity supplied there. But the figure is helpful to answer the questions about the tax incidence. If the government imposes a tax of $15 a month on internet services, figure 7.1 shows that the buyer pays $30 a month for internet services. You can see that the supply line with the tax starts here at 15 and then parallels the original supply line, comes up here to $30 now for the price of internet service. If the government imposes a tax of $15 a month on internet services, the seller receives $15 a month for internet services. So that is, the amount the seller receives doesn't change. The buyers pay more of the tax. Actually, the buyer pays all of the tax. And the government receives the extra $15 a month on internet service. Then you may wonder about the darkened triangle here. That's the deadweight loss from the tax incidence. That is that tax increase there. And that can be calculated by determining the area of the triangle, 1/2 base times height. But we'll move on. Using figure 7.2, which shows the demand for on-campus housing to work problems 4 to 6, the college has 200 rooms to rent. If the college puts a rent ceiling on rooms of $650 a month, what is the rent? How many rooms are rented? And is the on-campus housing market efficient? $50 a month, what is the rent? How many rooms are rented? And is the on-campus housing market efficient? Then we know from the start of the question that the college has 200 rooms to rent. So you can look at that chart and go up to 200 and realize that the equilibrium price for rent would be $600. People are willing to pay $600 for that 200th room. And I state that here, the equilibrium rent is $600 a month. The equilibrium quantity of rooms is 200 rooms. Now, there's a rent ceiling of $650 a month. Well, that's above the equilibrium rent. It does not change the market equilibrium. In other words, if there's a rent ceiling of $650 up here, but the price people are willing to pay is $600, that won't have any effect on people's rental habits or the market. The rent remains the equilibrium rent of $600 a month. The quantity of rooms rented remains 200 rooms, and the market remains efficient. Question 5, if the college puts a strictly enforced rent ceiling on rooms of $550 a month, what is the rent? How many rooms are rented? And is the on-campus housing market efficient? Explain why or why not. $550 a month is different. The rent ceiling of $550 a month is below the equilibrium rent, so the rent is $550 a month. At this rent, and you can go to $550 here on the chart, look down and see the quantity supplied of 225 rooms. 225 rooms are demanded, and the quantity supplied is only 200 rooms, so 200 rooms are rented. The on-campus housing market is efficient because the supply is perfectly inelastic, so the quantity remains equal to the efficient quantity. However, there is a shortage of rooms, and students spend additional time searching for housing. And with that scenario, it's likely that a black market will develop. That is, people will find ways to rent rooms below the ceiling. And that leads into question 6. Suppose that with a strictly enforced rent ceiling on rooms of $550 a month, a black market develops. How high could the black market rent be, and would the on-campus housing market be fair? Explain your answer. Well, the black market rent could be as high as $600 a month, which is the maximum rent someone is willing to pay for the 200th room. If a black market develops using the fair results approach, the market is not fair because the poorest students cannot afford the higher black market rent. Using the fair rules approach, the market is not fair because the rent ceiling blocks some voluntary exchanges unless the buyers and sellers are willing to participate in the black market. Question 7. The table shows the demand and supply schedules for student workers at on-campus venues. If the college introduces a strictly enforced minimum wage of $11.50 an hour, Who gains and who loses from the minimum wage, and is the campus labor market efficient or fair? Again, you can look at the chart, see at $11, there's the equilibrium quantity demanded and supplied at 400 at that price of at that wage of $11 an hour. Now the wage is going to change to $11.50 an hour. You can see the changes there. The workers who retain their jobs and are paid the higher wage rate gain from the minimum wage. The employer, the workers who lose their job, and the workers who must undertake extensive search for a job lose from the minimum wage. The minimum wage of $11.50 an hour is not efficient. There is a surplus of workers, and the marginal benefit to firms exceeds the marginal cost to workers. A deadweight loss is created. The minimum wage is unfair under the fair results approach because some student workers lose their job. The minimum wage is unfair under the fair rules approach because it blocks voluntary exchange. And again, if you're wondering about the surplus of workers, you can see that at $11.50 an hour, 300 workers are demanded, 450 workers are willing to work at that wage, so there's a difference of 150 workers there. Question 8 shows the demand and supply schedules for mushrooms. Suppose that the government introduces a price support for mushrooms of $6 a pound. Who gains and who loses? What are the quantity of mushrooms produced, the surplus of mushrooms, and the deadweight loss? So price support here, $6 per pound of mushrooms. And you can see that the equilibrium price is $4 per pound, and the quantity supplied equals the quantity demanded there of 3,500. So in questions like this, it's helpful to draw a graph so you can see the deadweight loss area more clearly. If the government introduces a price support of $6 per pound, production rises to 4,500 pounds per week. Mushroom producers gain from the price support. Mushroom consumers and taxpayers lose from the price support. There's a surplus of 2,000 pounds per week. And you can see here on the chart the support price of $6 is up here. The equilibrium price is $4 here. The quantity supplied was 3,500 at that price. So now with this new support price over here, there's a difference of the amount supplied here of 4,500 versus the old price of 3,500. So that's a difference of 1,000 pounds of mushrooms. And there's a difference in the price as well. So we can calculate the deadweight loss by looking at that chart. Figure 7.3 can be used to calculate the deadweight loss. The deadweight loss is the area of the darkened triangle. The area of the triangle is equal to 1/2 the base times height. In other words, it's going to be base here and the height here. So the deadweight loss is half of 1,000. The 1,000 again is 4,500 minus 3,500, so that's 1,000. And then the height difference, $2 down here, $6 down here, that's $4. So you can multiply 1/2 times 1,000 pounds at $4 a pound, which is $2,000. Use the following news clip to work problems 9 and 10. The headline states, coal shortage at China plants. The government of China has set price controls on coal and gasoline in an attempt to shield poor families and farmers from rising world energy prices. Chinese power plants have run short of coal. Sales of luxury, gas-guzzling cars have increased, and gasoline consumption has risen. Oil refiners are incurring losses and plan to cut production. Question 9 states, are China's price controls price floors or price ceilings? Draw a graph to illustrate the shortages of coal and gasoline created by the price controls. And China's price controls are price ceilings. So in the face of increased demand, China's price controls have kept the price from rising to its equilibrium. As a result, the quantity demanded exceeds the quantity supplied, and shortages have resulted. And figure 7.4 illustrates the situation in the market for coal. The figures for gasoline are similar. In figure 7.4, at the controlled price of $5.50 a ton, the quantity of coal demanded is 100 million tons per week. The quantity of coal supplied is 97.5 million tons per week. So there's a shortage of 2.5 million tons per week. You can see that on the chart here. Quantity of coal, of millions of tons of coal per week, and the equilibrium price of 600, price ceiling down here of 550. Question 10, explain how China's price controls have changed consumer surplus, producer surplus, total surplus, and the deadweight loss in the markets for coal and gasoline. Draw a graph to illustrate your answer. And this graph gets a bit complicated with all the different letters. I'll go over that. China's price controls aim to keep the price from rising to the equilibrium level. A price ceiling decreases the quantity available to the quantity supplied at the price ceiling. In figure 7.5, the quantity with the price control is 97.5 million tons of coal per week. Here's the price ceiling. Here's the 97.5 right here on that chart. Because the price and quantity decrease, producer surplus decreases. Because the quantity decrease and search costs are incurred, consumer surplus decreases. Because the quantity decreases and the marginal benefit exceeds marginal cost, a deadweight loss arises. Figure 7.5 shows the changes in consumer surplus, producer surplus, and deadweight loss. With no price ceiling, the consumer surplus is equal to the area A plus B plus C. So it's going to be this area here, A plus B plus C. That would be the without a price ceiling, the consumer surplus. And why that area, not E and F? Well, because here's the price of 600. So that's the equilibrium price line. Without the price ceiling, here's the area of the consumer surplus. That is that area underneath the demand line, ABC. With the price ceiling, consumer surplus is equal to area A. So now with this price ceiling, it's simply this area A. And why is that? Well, because of the price ceiling here at 550, go up here to where this price ceiling price would intersect the price, the demand line here, and you'll just get this tiny triangle A right here. So a huge change in the consumer surplus. The search costs are equal to the area B and E. In other words, this is the time the consumers search then for the good. The producer surplus without the price ceiling is equal to the area E plus F plus G. So that's going to be right here, E, F, and G. And again, why those areas? Well, because that's below the equilibrium price of 600, that price line there. So this area here under that price line would be the producer surplus without the price ceiling. With the price ceiling, the producer surplus is equal to area G. So with that price ceiling, then it's just going to be underneath the price ceiling line here of 550. The producer surplus is just that tiny area. Without the price ceiling, there's no deadweight loss. In other words, if that's at that equilibrium price of $600, there's no deadweight loss. But with this price ceiling now, there is a deadweight loss. That deadweight loss is the area equal to C plus F, and the area B and the area E are resources lost to search activity. So the deadweight loss is going to be C and F here for the deadweight loss, C and F. And again, why that point there? Well, here's the price of 550 intersecting the supply line there, up the demand line there. So just this total triangle, C and F, would be the deadweight loss. And then B and E, that's going to be the resources that are lost to searching for the good at the price. Hope that's helpful. Please let me know if you have any questions about these checkpoint questions or any other questions within the textbook.